Okay, we have National 5 2014 paper 2 calculator paper. Just going to go through the solutions. Question number 1, standard percentage question, is a decrease. So after 1 year, there's 15% less than what we originally had. So the original amount's 100%, subtract 15 is 85%, which can be written as 0.85. What will be the expected roll after 3 years? Well, after year 1, there'll be 0.85 multiplied by 964. After year 2, there'll be 0.85 multiplied by the amount after one year, after year 1 even. And after the 3rd year, it'll be 0.85 multiplied by the amount after 2 years. So essentially, we're going to multiply by 0.85 3 times. So we can do all of this in one line. So 0.85 cubed multiplied by the original amount is 592.0165. Make sure you read the question, people. Give your answer to the nearest 10. So you're getting a mark for rounding to the nearest 10 there at National 5. That is a gift. Make sure you read the question. On to number 2. The diagram shows a cube. It's an important bit there. This is a cube up here, placed on top of a cuboid relative to the coordinate axes. A is the point 846. So to get to A, we go 8 along, 4 in the y direction, 4 back, and 6 up. So let's have a look how that affects the cube. Well, 8 along doesn't tell us how long the cube is. 6 up won't tell us how high the cube is. But the 4 back tells us that the cuboid and the cube are both have a breadth of 4. And as it's a cube, it'll be 4 by 4 by 4. So that's the important information that we need to write down the coordinates of B and C. Well, B will be 4 higher than A. So that'll be 8 along, 4 back, and 6 plus 4 high, which is 10 high. And point C, well, again, we know what 846 is. Would have to go 4 in this direction, so 4 back in the y direction, 4 along in the x direction, and 4 up in the z direction. So that would give us 4, 0, 10. Number 3, again, quite a standard question, quite a generous question, simultaneous equations. Part A, write down an equation to illustrate the information. So 5 adults and 3 children pay £158.25p. 5A plus 3C equals 158.25. Part B, Ben buys 3 adult tickets and 2 child's tickets. So 3A plus 2C, and that costs £98 equals 98. I've put 0.00 there. There's no real reason to do that, except we've got 2 decimal places above, so I thought it might have been handy to do so. Part C, calculate the cost of a ticket for an adult and the cost of a ticket for a child. So we need to scale these to make the coefficient of A and C equal, or in other words, get the same amount of A's or C's. So if we double the first one and triple the second one, we'll get 6C and 6C. So remember, double absolutely everything. So double 5A, double 3C, double 158.25, and we get 10A plus 6C equals £316.50. So I'm calling that equation 3. I'm also writing where it comes from. That's important. I've taken equation 1 and I've doubled it. You guys should definitely be doing this. If you're not, if you make a mistake, you'll be losing all of your method marks. 3A plus 2C equals 98. Again, I'm going to triple this equation, so I'm writing it down here. Equation 2 multiplied by 3, calling that equation 4. So 3 times 3, 2 times 3, and 98 times 3. So if I know 10 adult and 6 children's tickets are that much, 9 adult and 6 children's tickets are that much, we've basically got an extra adult's ticket up here, and we're paying an extra £22.50. The way to show that algebraically was going to say equation 3 subtract equation 4. Again, the reason why you're doing that is saying, right, well, actually, what's the difference? Well, this is an extra £22.50, and we're getting 1 extra ticket for it. So this extra ticket has to cost £22.50. Right, so we know an adult's ticket is $22.50. Substitute that value back into either A or B. I'm going to put it into B because the numbers are a bit smaller. So 3 lots of $22.50 plus 2 children's tickets will be £98. So $67.50 at 2 children's tickets is still £98. So subtract $67.50 from both sides, divide through by 2 to get the cost of a child's ticket, $15.25. State that clearly as well. Just below here I've checked by substituting my 2 values back into equation 1 just to make sure I get the answer of 158.25. Number 4, it's the standard deviation question. It should be quite straightforward if you've done your revision. Part 1, find the mean. You could probably do this in primary 7. Add up all the numbers, divide by how many numbers you've got. 56.5. Part 2, calculate the standard deviation of these lap times. Show clearly all your working. So standard deviation, there's 2 formulae for it. I use this one. Sum of x squared means add together all the x squareds. So that's take all of the values, square them, add them together, let the calculator do the work for you guys. So 53 squared of 57 squared, etc. 19,183. This part, the sum of x, that's adding together all the values, 339, squaring them, then dividing them by n, which is the number of values, which is 6. 1, 2, 3, 4, 5, 6. There we go. Then just substituting in. Then I'm going to evaluate all of this divided by 5 on the calculator. I'm going to square root it to get 2.43. Let's round it to 2 decimal places. Part B, she changes her training routine, hoping to improve her consistency after this change, etc., etc. The mean is 55 and the standard deviation 3.2. Has the new training routine improved her consistency? Which value, the mean or the standard deviation, takes into account consistency? Standard deviation is the average distance from the mean, which does give us an idea of consistency. The further you are, the further away from the mean on average you are, the higher the standard deviation. So originally it was 2.43. It has increased to 3.2. So has the new routine improved the consistency? No, her times are now more spread out as the standard deviation has increased. If you just write the standard deviation has gone up, you wouldn't get any marks. You've got to show that you understand the link between spread or consistency and standard deviation. Number 5. Just having a look here, scale factor question. You can find the scale factor between the heights, and we'll want the volume of the large cookie jar. We're told this is 750 in the question, so we need to find the volume of the larger one. So when we're looking at the scale factor between the large one and the smaller one would be 24/15. We could work that out. There's no real reason to do so, because once we've got this, we would cube it to get the volume scale factor, then multiply it by the volume of the small tin, and it comes out as 3072 centimeters cubed. So it gives us 3 sides of a right angled triangle. Lowtown and Midtown are, well, Lowtown is due west of Midtown, or Midtown is due east of Lowtown. Same as Hightown north. Well, if Hightown was north, this would be right angled, and we'll need to find out if it is a right angled triangle. So we do the converse of Pythagoras. So we look at the long side squared. We look at the 2 shorter sides squared added together. If those values are equal, then it is right angled, but they are not. 75 squared plus 85 squared does not equal 110 squared or 12,100. So the triangle is not right angled by the converse of Pythagoras theorem, and Hightown is not north of Lowtown. Again, that's because that's not a right angle. Number 7, don't really like the diagram. This is meant to be a cone with a hemisphere cut into the bottom of it. Looks a bit strange. Hopefully it didn't put anybody off. So what do we need to do? We need to find the volume of the cone once the hemisphere has been cut away. So I'm just going to write that down, show clearly my thinking. So the volume of the cone would be 1/3 pi r squared h, which is 1/3 times pi times 4 squared, because the diameter is 8, therefore the radius is 4, multiplied by the height, which is 15. And we've also got the hemisphere. Well, a whole sphere would be 4/3 pi r cubed. So hemisphere would be half of that amount. So half times 4/3 times pi times 3.7 cubed. Again, diameter is 7.4, radius is half of that. And subtract those values. And two significant figures, well, I've got hundreds, tens, units. So the second significant figure is the 10, or the tens column. So 45.24 would go to 50, so it'll be 150 centimeters cubed. Question number 8. Just multiplying the top together. N to the 5 times 10n would be 10n to the 6. Because if we multiply powers together, we just add the powers. And then we've got 10 of them, so just put the 10 at the front, over 2n squared. If we're dividing powers, so n to the 6 over n squared, we can just subtract them. And 10 over 2 is 5, so we'll get 5n to the 4. If you're not getting those rules, ask your teacher about them. You definitely need to know the rules. There's about 8 of those rules that you need to know off by heart. If you're thinking about doing higher maths, you definitely need to know those rules. Otherwise, it will be a very unpleasant experience for you. Number 9, standard algebraic fraction question. We need to have a common denominator, so I'm going to multiply top and bottom here by x, and top and bottom here by x plus 5. So when we're doing that, we have x plus 5 on the bottom of both fractions. So we can write it all as a single fraction now. I'm going to have 7x minus 3x. Well, here we have minus 3 multiplied by 5, so that'll be minus 15. Quite easy to make the mistake and write plus 15 there. And just tidy up, 7x minus 3x is 4x, subtract 15. No need at all to multiply out at the bottom of the fraction there, because we've got it in its simplest form. Question number 10. An array sports sale around 3 boys, etc. So this side's 8, this side's 11, this side's 13. It wants angle A, B, C, so like this angle. We have 3 sides and we're looking for an angle. So if I look at my formulae list, I should say, on the front, near the front page, the only one with 3 sides and 1 angle is the cosine rule. So I would use cos A equals B squared plus C squared minus A squared over 2BC. Now I can choose to rearrange the formula, because this is angle B I want, not A, or it could just be a little bit more sensible and say, right, I'm going to call this one A instead of B, and that one B instead of A. Then it's easier to substitute in. So little a would be 13, little b would be 11, little c would be 8. Substitute the values in. We can simplify this, but there's no real need to do so, because we're just going to find the inverse cosine of it. And it comes out as 84.8. So this angle here is 84.8. And again, just stating at the very end, I've been asked for angle ABC. I'm just making it really obvious that angle ABC is 84.8 degrees. Hence, find the size of the shaded angle. Well, what do we know? We know that this is 84.8. Not really got enough information to work this out yet, but if I could work out this angle here, add it onto that angle and subtract it from 360, I would get this angle. So I know this is 60, I know these two lines are parallel. So depending if we like F or Z angles the best, turn this into a Z angle, that's north, so this will be south. So those two would be 60. This is a straight line, that'd be 120. So 120 at 84.8, add the missing angle, would be 360. Subtract 120 plus 84.8 from both sides, the missing angle will be 155.2. Number 11 again, hopefully easy marks for you. Rearrange to make what we're looking at A the subject. So we need to get all of this bit on its own first of all. So subtract ut from both sides. Got half at squared, so divide both sides by t squared. I'll move the t squared over and divide it. Then we've got a half, so multiply both sides by 2. So we'll get 2 lots of s minus ut over t squared. And because we're asked to make a the subject, it should read a equals rather than 2 bracket over t squared equals a. So just there we are, there's the last line. Number 12, again, quite a generous question. There's no problem solving element to this. This is essentially a unit test question coming in near the very end of the paper. So quite generous, really. Add 2 to both sides, divide through by 11 to get what cos x is. Going to use a little ASTC diagram. This tells us when things are positive. Cos is positive here. We've got a positive value of cos x. We're looking in the A and the C quadrant. I could go into this question in more depth. There are YouTube videos of the reason why this works. Ask your teacher or look online, guys. It'll take me 10-15 minutes to explain. Or if people want it, I'll happily do a video on it, but you must request it. Just put a request online. So then we do the inverse cos at 5/11, which is 63 degrees. And this quadrant is 360 minus x, so it'll be 360 minus 63 to get the second answer. So 63 or 297. Number 13, last question. Looks like the standard Pythagoras in a circle question, but it isn't actually. We did have a Pythagoras in a circle question in paper 1. The diagram below represents a cross-section of the tunnel. The center is O, MN is a chord, angle MON is 50. The radius is 7. Calculate the area of the cross-section. So in 2 parts, we've basically got a triangle. And here we've got a fraction of a circle, or a sector of a circle. So triangle, area equals a half AB sin C. Call this one A, B, C. No, sorry, call this angle C, because it's a half AB sin C, so you've got to have sin of the angle that you know. Half times 7 times 7 times sin 50. I should really have had a diagram there. Just evaluate that in the calculator. And the sector area, or what fraction of the circle we're looking at. We're looking at whatever 360 minus 50 is. So we're looking at 310 degrees here, or 310 360ths of the area of the circle. So the area would be pi times r squared, pi times 7 squared, but we've only got a fraction of that. We've got 310 360ths of that area. So just type that in, how it comes, add the 2 areas together, round up to 1 decimal place. That's that question answered. So quite a fair paper, I would say. The one next year might be a wee bit tougher.